Hello, hello, and welcome! Here we are, Grimlight Games. We're back at it. So, you may notice from last episode that we've got something different going on here. So it was a little bit of a difficult decision, but I did end up nixing my last project. Now, I haven't gotten rid of it. It still exists, but I decided to put a pause on that because I found a series of courses that I can utilize to really build separate systems as opposed to just kind of following someone start to finish in creating a little rudimentary game. And we're going to be using these to set up a skeleton framework that we're going to end up completely reskinning. And honestly, I kind of want to turn this into my first solo project. Now, I say solo. Obviously, we're going to be following along with some lectures. We're going to be learning about some new systems in Unity. So that was the other thing, too. These lectures have streamlined some of the more newer aspects that Unity has released. So I'm excited to learn about those. And they've made things a little bit easier. So just to show you real quick, just one of the simple things that I didn't even know about that I have now learned. Using a linear sorting layer makes it so much easier for object sorting. This was arguably one of the more difficult things I was setting up in the last project, was just making it so we could walk behind certain objects and not get clipped by it, but then, still have collision where there should be collision. So this just made it so much easier. There's also a completely different way to program the character controller in this one that I really like how it approaches as well, and it's going to be so much easier for me to add to that method. So that way we can utilize a gamepad or other things in the future. So, yeah, that's where we're at. That's why we started this brand new project. So, a background on it. This is a lecture produced by GameDev.tv. You can find their stuff on their website, or you can find it at the Udemy website, which is where I pick up my lectures from. Oftentimes they're running really great sales. You can get some really great prices on tons of things, not just courses for learning C# or learning Unity or game development, but there's tons of things on Udemy you can get into. So, yeah, that's where we're at. We're gonna jump right into it where I had left off as I was working on this. So what we've built already. Oh, sorry. One last thing for house maintenance. I have abandoned Microsoft Visual Studio, and I've decided to use Visual Code instead. So I had explained in the last video how I was running into trouble opening up my solutions, and it was just really more of an annoyance. I would have to open Microsoft Visual Studio, and then I would have to force close it, and then open it again, and then open each individual file within the solution, and it just kind of got tedious for setting up. And I thought it was just my last project that was corrupted somehow. But no. Sure enough, I started a new project, this project that you're looking at, and when I wrote out my first script, saved it, went back to it later, I ran into the same issue, just trying to open up one thing. So something is bunked up there. I attempted to fix it all again. I went through all the different steps, all the things I could find, reinstalling, modifying, fixing, taking it off the computer, putting it back on, and it won't work. So maybe it's one of my extensions that I have, but last time I did try disabling my extensions, and that didn't work either. So far, Visual Studio Code seems to be working great. It's a little bit different than what I've been used to, so it is going to take some getting used to. There's a lot of things that are the same, but yeah. So, there. That's where we're at. Okay. Let's go ahead and get rocking. We finished the player movement. So what you're looking at right now, this is our player controller that we built, and it's utilizing the controller system is something new that I haven't done before. So it's this, doing a player control map. That was really cool. Never done that before. Edit it. Just can kind of open it up to show you how this is going to work, right? So we've got our action map, and currently it's set the function to movement. And inside that function, we have move on a 2D vector. We have up linked to our W key, down to S, left to A, etc. So we can build another thing on top of this, and for our path, we can actually use gamepad, joystick. I mean, like, see, there's so many different ways we can very easily, quickly map out movement moving forward. So that's what I really liked about this system, as opposed to just trying to hard code it into the game. So there we go. All right. I believe today we're going to start by unable to find style toolbar search text field in skin, dark skin used. Okay. Not sure what that's all about. So we're going to play again real quick, see if that's an issue. Nope, looks fine. Okay, not sure what that was about, but I digress. Today we're going to be working on our enemies, getting them to move around, and we'll see what we've got in store for building our AI, for patrolling, how it seeks and attacks the player, and making sure that the AI can navigate around our objects as well. Nope, that's not the play button I needed. Whoopsie.
Let's make a player folder. I'm going to go ahead and drag these in.
Okay.
Easy peasy, lemon squeezy.
So we just kind of organized our sprites folder here. Got everything situated and set.
Tree into the environment it goes. Gonna go ahead and make a miscellaneous folder just for things like shadows and whatever else we feel like might not fit anywhere else. And one more, let's make an enemies folder before we get too clustered. And I think keeping the presets thing over here makes sense too. Okay, let's keep things simple and take things one step at a time. We're going to largely be implementing
I've also got my notebook out here, so I can take some notes as we're going along as well.
To essentially handle our enemy's state.
So what we're going to be tackling, and this is what I was really interested in with this particular program, is the state machines. I started messing around with those on my own a couple months ago, and I really wanted to dive in and learn more about those, and I was really pleased, excuse me, that they're utilizing state machines within this lecture, so it'll be a little bit easier to learn how to code them in and to see how they work with everything going about, instead of just trying to like figure it out from square zero.
What it's doing, whether it's roaming, whether it's attacking, maybe it's shooting a projectile, maybe it's chasing the hero, or really whatever we want. And it's going to talk back and forth a little bit with our pathfinding script, which is going to handle some basic enemy movement. Now, this might get a little bit confusing and a little bit complicated, but I'm going to do my best to keep things intuitive, going one line of code after one line of code in a way that if I was creating a project like this, I would set it up without overcomplicating things right up front. Perfect. Let's go ahead and create those two C# classes that we talked about. Let's make an enemy AI C# script, and I think while we're here, we can go ahead and also make the enemy pathfinding script.
So we'll set up our two scripts.
And rename both of these shadows, because ahead and also make the enemy pathfinding script.
Cool. We've got our enemy AI class, and now we'll have enemy pathfinding class. Perfect. Let that compile. Cool, cool.
Just gonna go ahead and rename both of these shadows because shadows underscore underscore sheet 1 is a little bit ugly. And before we head on into VS Code, let's just go ahead and add our enemy AI script and our enemy pathfinding script to just our slime.
I'll collapse these so they're out of our way. Good. All right, now we've got both scripts on
And
there.
we'll probably prefab it once we get back, but let's just start with one at a time. All right, here we go. Let's go ahead and hop into our enemy AI script. All right, let's try to handle this and tackle it one line at a time. For now, we want this script to determine a new random position for the enemy to move every couple seconds and also relay this random position to the enemy pathfinding script, which will be responsible for doing the actual moving. We know we need some kind of private state, so let's go ahead and create that as an enum up top. I'm just going to go ahead and call it state.
Ah, yes.
For now, we
I remember
only need the
enums from when I
roaming
was
state.
trying to
Let's not
figure
get
it
ahead of
out.
ourselves. I'm going to go ahead and initialize that as a lowercase state and set that to roaming in awake. So simple enough, state equals state.roaming. Perfect. Now, we also know we're going to need our enemy pathfinding component that we also attach to the same game object. I'm just going to go ahead and call that lowercase enemy pathfinding. And same as we've done before, and we'll do many more times, I'm going to go ahead and initialize that in await by get component enemy pathfinding. We know we're going to need some kind of coroutine to fire every few seconds. So let's go ahead and start that. I'm just going to call mine the roaming routine. And inside of that, we want it to fire every few seconds, so we're going to use a while loop. Well, what's nice about holding state is we can continually fire this if it's roaming. So that's simple enough. We can basically just say while state equals state.roaming, go ahead and fire whatever is inside this while loop continuously as long as we tell it to. For simplicity, for now, I'm not going to overcomplicate things. I'm just going to fire it every 2 seconds, and I think that'll give us a good example of what's going on. So yield return new, wait 4 seconds, and let's just call it every 2 seconds. Well, what are we calling? Let's create a new function that's going to return us a vector2, and let's call it private vector2 get roaming position. Well, that's easy enough, and that is going to simply return a new vector2 that is going to give us a random direction. So how do we do that? Random.range in between the -1 float value and the +1 float value for both the x and the y. I'm going to go ahead and copy and paste that. And very important, we do need to normalize this vector to make sure it's not going quicker in a diagonal direction. We want to get that vector2 every 2 seconds. Let's just call it roam position. And every 2 seconds, we are going to get the roaming position. Did I spell that right? Yeah, perfect. I think the last thing we need to do is in start. Let's just go ahead and start our coroutine.
All right. He codes super quick. I am not quite up to his level. So I'm going to pause that video. I'm going to kind of process what we just did, catch up, and then, yeah. Yep, I'm still down here. Alright, we've got our IEnumerator. Roaming routine. Nope, that's not correct. Routine. Okay, good. Got that set. Got get roaming position. Oh, because we don't have that yet. That's why it's doing that. Okay. Private vector 2 here, and then this is where we're going to set up our get roaming position, which it's calling for. So it'll be utilizing random range for this is roaming, the roaming routine, right? I mean, we said that right when we were setting up the enumerator. So random range, so it can kind of pick a spot between those numbers. Good, we like that. And then we'll need the second. Okay. It's an ambiguous reference. Right.
Our enemy pathfinding component that we also attached to the same game object. I'm just going to go ahead and call that lowercase enemy pathfinding. And same as we've done before, and we'll do many more times, I'm going to go ahead and initialize that in a wait by get component enemy pathfinding. We know we're going to need some kind of coroutine to fire every few seconds, so let's go ahead and start that. I'm just going to call mine the roaming routine. And inside of that, we want it to fire every few seconds, so we're going to use a while loop. Well, what's nice about holding state is we can continually fire this if it's roaming. So that's simple enough. We can basically just say while state equals state.roaming, go ahead and fire whatever is inside this while loop continuously as long as we tell it to. For simplicity, for now, I'm not going to overcomplicate things. I'm just going to fire it every 2 seconds, and I think that'll give us a good example of what's going on. So yield return new, wait 4 seconds, and let's just call it every 2 seconds. Well, what are we calling? Let's create a new function that's going to return us a vector2, and let's call it private vector2 get roaming position. Well, that's easy enough, and that is going to simply return a new vector2 that is going to give us a random direction. So how do we do that? Random.range
That's
in
why
between the
I'm all
negative
messed up.
1 float value and the positive 1 float value for both the x and the y. I'm going to go ahead and copy and paste that. And very important, we do need to
Maybe
normalize
not.
this vector to make sure it's not going quicker in a diagonal direction. We want to get that vector2 every 2 seconds. Let's just call it roam position. And every 2 seconds, we are going to get the roaming position. Did I spell that right? Yeah, perfect. I think the last thing we need to do is in start. Let's just go ahead and start our coroutine. I'm going to go ahead and delete that.
Maybe that's why I'm messed up.
Start coroutine, roaming routine. And just to make sure everything is working correctly, I think we should be able to debug.log our roam position every 2 seconds. Let's go ahead and give that a try. Gonna go ahead and head back into Unity. Nice. So right off.
Hang on, buddy.
debug
You're moving too
roaming
quick for me.
routine. And just to make sure everything is
Okay. Yeah, we need to set that as the function.
working correctly, I think we should be able to debug.log our roam position every
Enumerator. So this way we can just see the printout of what it's doing.
2 seconds. Let's go ahead and give that a try. Gonna go ahead and head back.
Of course, I'm still worried about why this is. It's an ambiguous reference between UnityEngine.vector2 and System.numerics.vector2. Using System.numerics. Wait a minute. Why? I think the IntelliSense may have added something for me that I didn't want in. So again, unfortunately, this is kind of where we're running into. We're using a new coding system. So that's, yeah, there's no system numerics in this, so I think that's what's going on here. It created that when it auto-completed that without me telling it to. So what I want to look for is I want to set the IntelliSense to only execute when I tab. Unless, maybe I messed something up. Maybe I hit tab and I wasn't paying attention to what was written in front of it. But anyways, I mean, we figured out what the problem was, right? Is something got added in via IntelliSense that was conflicting with what we were doing. One problem. Didn't I just fix... Oh. Oh, that's what the problem is. Cool. Okay. Now everything's situated and working here. Let's ask... Okay. All right, good. So, we go through here with our little gear code. Settings, search bar. There's probably something else I'm supposed to... Search settings. Okay, so now we've got our settings search bar. Okay. I am confused. Maybe I'm supposed to put it in these. Nope. How about... Here we go. Okay. We want to uncheck editor accept suggestion on commit character. So this will prevent suggestions from being automatically set. And then uncheck on enter. Only accept a suggestion with enter when it makes a textual change. No. Okay. So I think that'll do it, right? So now our IntelliSense should not... Oh, cool, look at that. Well, we got 2 new viewers while we were working on that, but by viewers, I mean they were just robots that were reported as a likely harasser. They were restricted. Cheap viewers on star, whatever the heck that is. So that's great. Apparently I can still attract robots to my channel to harass me, but not actual real people. Sad day. Sad day. Okay, anyways. So we got our IntelliSense situated correctly. So yeah, there's a nice little snippet for you. If you are struggling with IntelliSense in Visual Studio Code, go to your little gear icon, go to your settings, and then you can look for the editor:accept, because you want to uncheck suggestions on commit character and accept suggestions on enter. So now IntelliSense will only give you or make the change when you tab. Perfect. Please sign in to backup and sync your data across devices. Sign in. Guess we'll sign in with GitHub. I don't want to have to redo that every time, and apparently I have not set myself up yet. So we're going to go ahead and get that situated. Perfect. No, I don't need to open it. It's already open. Oh, here we go. Signing into GitHub. Hopefully I didn't just mess that up. T. No, okay. So I did have to open it. Settings sync turned on. Good, great, awesome. Okay, so now we shouldn't ever have to mess with that again. Fantastic. Did I save this?
Back in Unity. Nice.
There we go.
So right
We'll let
off the
that
bat,
compile.
Every 2 seconds, we're getting a...
So now we just want to see if we get our debug log going. Okay. Oh, good. Yep. Every 2 seconds, we're getting a new random range. Fabulous. Okay.
new
good.
random direction on a vector 2 that we can use for our slime to move somewhere. And with that comes your challenge. Set up our enemy pathfinding class to use this vector 2 in a way to get our slime randomly moving around the scene. But try to reference our player controller class that we've already created as much as needed. In other words, you should be able to use the slime's rigid body.move position in a very similar fashion as we did with our player controller. Go ahead and give that an honest effort, and I'll see you back here in a few minutes.
Okay, so now it's challenge time. So what we're going to do is, with what we just set up in our enemy AI, we're going to use, or we're going to make references to our player controller to get our enemy to randomly move. Okay? All right, so let's see. So part of this, right, we're going to do a little bit of research, and we're going to utilize our tools at our disposal to try and solve this problem on our own. And then, of course, we're going to watch him solve it afterwards and see if we did it right, if we did it wrong, if maybe his way of doing it is better than ours, or maybe our way is better than his. Okay. Okay, so let's see. How are we going to do this? We want our enemy to choose a random destination within our game world. We want the movement to be constrained within the scene so he doesn't end up moving outside. Okay. We want to utilize the rigid body. And we're going to reference the player controller as often as we need to solve this problem. Okay. Okay. So, we're going to need our rigid body, right? No. What we're going to need first. Here's what we're going to need first. We need our vector 2 to be stored as the roam position. Now we need our rigid body. So that way we can move the object. Of course, that's going to be RB, nice and simple. And we're going to need serialized fields for the move speed and for the radius of the roam. Okay, this makes sense. And so far it looks like IntelliSense is working the way we want it to. Fantastic. We'll make that a float. Move speed. And you know what? We're gonna... I'm trying to decide if I want to give it... You know, we'll set it... I mean, it's private. We could make it public, and then we could change it within the game. So we're going to set it to that, but we're going to make it public. All right. Oh, I was like, wait, what's going on there? I didn't set it to be a float. Okay. All right. So we're good there. Now, obviously, since we put in the rigid body, we do need to have it get itself. All right, but I want to keep it uniform. How did we do it here? Okay. No. Wrong. What? Dang it. There we go. Okay. So it's already set to state. I want this to call before it, though. There we go. Okay. Our start function. We want to also get our roam position. Get roam position. Okay. I want to comment this out to help us as well. Right? Yeah. This handles the pathfinding. This will be our current roaming target. Yep. I don't need to comment this out. We know our rigid body is how we're going to move the object, our speed, and the radius in which we move. Okay? With this, we're going to set initial roaming position. Position. Okay. Once we started our core routine, numerator. So let's take this out. So while this is running, if vector 2 we're going to move this distance rigid body dot position roam position less than now this is where we're going to put what we just took out. Okay. Oh, what is this? Get out of here. Okay. All right, so if our vector 2's distance. So the rigid body's position and roam position is less than 0.2. We're going to call for roam position, get roaming position. So basically, if enemy reaches their target, get new target. Yep, right? Yes. And this is get new target. Right, because our get roaming position. Well, we're going to add our roam radius to that. So that way we can hold everything inside of there. Yes. We still need everything to wait before the while loop continues. But while we're waiting, we'll set up a new function. And this will be our actual moving function. Okay? Yes. Okay, so let's make sure that our get roaming position works with all this. Then we're going to set up our move to roaming position function. So we want random direction, right? Random direction, random position. So let's do, this will be our random direction. Do we have anything set for that yet? Where are we going to call for that? Declared but never used. I guess no. We'll okay. This is how we'll determine it. We get the vector 2. Transform, because we're moving. So we'll add random direction, which we've already established. So every 2 seconds, we get that new direction. And we want to multiply, right, by our random range. Which will be the roam radius. Yes. Okay. And then return random position. Boom. Okay. So let's rationalize these thoughts, okay? So with our random direction and random position, we are finding random position that is within our radius, our roam radius, from our current position. Okay? And then we just return the position. Right? Yep. Because we need that to get that. Now let's set up our other function. See if we can make this work and explain why it works. Because that's the most important part. Making it work is great, but for me to learn, I need to understand why it works. Move to roaming position. There we go. We'll set our function and our brackets. So this is what's going to happen inside of that function that we called for. We'll get our vector2 direction. That's going to be equal to our roam position minus the rigid body's position normalized. Booyah. Position plus direction times move speed. And then our fixed delta time, so that way it's moving frame independently. Right? Well, obviously, I mean, we kind of know, right? This is going to move towards position. Okay. So, in our state setup, the enemy begins roaming. It will move randomly about within the radius that we set. The getRoamingPosition function is going to calculate whatever the radius is. And that will be a radius around where the creature is placed. So that'll be universal. Then, of course, we have our move to roaming position, right? So this function is going to move the current target roaming position by calculating the direction and then applying movement to the rigid body. Right? Because we need our rigid body to get 2D movement. Yes. Yes. Okay. This is making sense. This is making sense. The logic for the roam. Our enemy is going to be continuously checking whether or not they've reached the target that they're trying to get to. The threshold distance, we're using 0.2, so that way it's almost guaranteed, or should be guaranteed, that they will hit their target. They will be within their target close enough to get it to re-trigger. We are assuming yes. We're assuming, because we have a rigid body already set to our enemy. We can then reference our player controller. We don't have to do that yet, but we can reference the player controller so that way the enemy will be compared to the player's distance, pursue the player, and then if the player is X amount of space away, the enemy will then reset. Okay. That all sounds good. Okay. So let's try this out. I don't see any issues in the script. We'll save it. We'll head back to Unity. Okay, so if we did this right, our slime, which has the script, right? And because I made those public, we can adjust our speed and we can adjust the radius of the roam. In theory, our slime should start moving around. Very slowly. Well, he's moving. What's going to happen if he runs into a solid object? Looks like he reached his destination and he's changing direction. Oop! And I pushed him. Alright. So, interesting. I'm looking at... where's the player controller? So, our move speed is 4. And we move a lot faster than this dude. It's also kind of choppy. It's not like a smooth progression towards where he's trying to get to. But I mean, the good news is we've got this working, and we understand why it works. Let's see what happens. Bump. Okay, you've hit the tree. You can't keep going. Oh, is he trying to get around the tree? Okay, so with 50... Oh, you look like you kind of got stuck. Are you still stuck? Yeah, I think bumping into the tree may have broken him. Alright, so there's definitely going to be some things to consider that we're not quite ready for. Alright, but that's cool. I'm pleased. I'm pleased with that. Alright, let's see how he did it.
Welcome back. I hope you gave that an honest effort, but let's go ahead and go through it together. Now, I'm going to go ahead and use the VS Code. I believe it's the default hotkey. I'm going to press Control and P at the same time, and I'm simply going to type in pathfinding to find our enemy pathfinding. We have our enemy pathfinding up.
Okay. So I did it inside of the enemy AI script. Uh-huh. It looks like he is going to do this differently. Which makes sense. I really should have... Because the enemy AI is supposed to be our state machine. Yeah, I kind of pooped that up. Okay. Well, we're going to follow along and see what we did right and what we did wrong.
Go ahead and delete this, even though we might need it in just a second. And this script is going to be responsible for moving our enemy to the random position that we set in our enemy AI class. And let's have a think about what we're going to need. Well, we're going to need some kind of move speed float, so let's go ahead and create that and just call it move speed, and I'll initialize it as 2 for now. I think our player was 4. 2 seems to kind of make sense. And we're going to need our rigid body.2D. We can go ahead and initialize that as RB. Going to go ahead and initialize that in a wake, get component.
Okay. So I mean, already you can see that we were thinking correctly. Right, did I need... I don't think we had the rigid body before. How do I... Control Z. Control Z, it's going to do quite a bit. There we go. We're going to undo all that hard work. Now, we definitely did not have a rigid body on this before. I remember now because we put that in. Right? Okay. Now, we are going to redo all this. Cool. Okay. So we just got rid of our serialized field. We're moving our rigid body over. So really, I want to see what we had right and what we had wrong.
I need it in just a second. And this script is going to be responsible for moving our enemy to the random position that we set in our enemy AI class. And let's have a think about what we're going to need. Well, we're going to need some kind of move speed float, so let's go ahead and create that. And just call it move speed, and I'll initialize it as 2 for now. I think our player was 4. 2 seems to kind of make sense. And we're going to need our rigid body.2D. We can go ahead and initialize that as RB. Going to go ahead and initialize that in a wake. Get component rigid body 2D.
Oh, cool. That's a lot much quicker way to do that.
And what else do we need? Well, we need that vector too. So let's go ahead and create that up top so we can use it whenever we need. Let's go ahead and create that vector 2 and just call it move dir for move direction.
All right. So I mean, so far that's pretty much what we did here, right? We got that, we got that. So then sets up the private vector 2 move dir. So this would be our roam position, right, that we set up. So we're going to move that over too.
Oh, somewhere in fixed update, we can modify our physics very similar to as we did with the player. So I could probably even just go and copy paste this. Let's actually do that to kind of bring the point home. I'm going to go ahead and click here, Control C and Control V.
So we're looking at what's in our fixed update. Right. And not direction we want, movement.
Perfect. Now we're not using the movement vector 2, we are using the move dir, but everything else is the same. Ha, well, that's easy enough. But how do we update this vector 2? Well, one way to do it is we can create a public void move to function that takes in a vector2 as a parameter that we can just call target position. And when that function is called,
Yeah. You know what, to keep it... No. Man, I was way off. This is very different than what we were setting up.
anywhere else in our project, it's simply going to update our move dir vector2 as the target position. Nice.
So we'll take our roam position, and that will be our target position.
We're going to call that probably somewhere in here. I can probably just...
Alright, well, we've already figured out that we were wrong. So we're just going to go ahead and undo all of our hard work. I think we're all good with that now, right?
Just delete this debug.log, and in our enemy pathfinding, oh, what did I call it? Move to, yes. And simply plug in our roam position as our parameter. Okay, let's go ahead and give that a shot. Moment of truth. Go ahead and click play. All right, it looks like...
Man, his is so much simpler than what I was setting up. Wait, what did I mess up? Move to... No, that's not right.
Update our move dir vector2 as the target position.
Oh, Vetor. I was like, why isn't that working? Wow, really? Is that so much easier than what I just did? That really is, isn't it?
Nice. So where are we going to call that? Probably somewhere in here. I can probably just delete this debug.log, and in our enemy pathfinding, oh, what did I call it? Move to, yes. And simply plug in our roam position.
Wow.
Our parameter. Okay.
That's working so much better than mine. Look at that. That's huge.
Looks like our slime is moving. Oh, hey, look at that. And every 2 seconds or so, he is getting a random direction and moving into that direction. Hooray! We did it. Let's just go ahead and make that slime a prefab. I'm just going to drag a few more in for funsies.
Okay, looks like he also doesn't break when he bumps
Hey,
into
that looks
stuff.
pretty good. Go ahead and give yourself a pat on the back if you got this far. And I will see you in the next lecture.
Wow. Just updating our notes here. Man, that was so cool. Yeah. Fantastic. Absolutely fantastic. Oh, I'm so stoked. All right, let's see. Updating our notes. Current workflow. So our enemy AI script. The script is responsible for randomly selecting a roaming target position by calling the get roaming position. Let's go over this in our actual script, right? Okay, so looking at our enemy AI. So we have our get roaming position, right? Once the target position is selected, this script then tells our enemy pathfinding script to move towards the position using enemy pathfinding.move to roam position. Which is, where's our move to roam position? Here, pathfinding.move to roam position. Okay. So within our pathfinding script, we have our move to function. This sets the current roaming position. And then within our fixed update, we apply the movement to the enemy's rigid body. So the movement in our fixed update currently uses our rigid body position plus roam position. But roam position is the absolute target, not a direction. This will cause the enemy to move at an unintended direction and speed. To fix this, the enemy needs to move toward the target position. And we should calculate the direction vector and normalize it so that the speed remains consistent. So move speed. Interesting. So this is talking about utilizing a bool. I mean, we've already got that. Why doesn't it want to use a roam radius? See, the first in our first take, when we tried to do this ourselves, the roam radius was utilized and it worked. And I mean, everything appears to be working just fine there. Why does it matter? And the speed shouldn't change. The speed is what the speed is. So I don't know what you talking about. Goodbye. Where are you going, buddy? You're running away. So we definitely haven't confined it. That's fine. Okay. I'm happy with that. Actually, before we start our next lecture, let's see if we have enough time to keep going. I think we do. Yeah. Yeah, we can do one more. Let's do one more.
All right. What are a bunch of enemies running around if we don't have something to hit them with? In the resources tab of this lecture, I've got a sword sprite prepared for you. I'm going to go ahead and drag our sword sprite into the project. Easy enough.
Go ahead and open that up. All right. Two. And now we have our sword. But we'll move this. There we go.
And I'm just going to go ahead and drag that into our player game object. Zero it out a bit and position it accordingly. So I'm going to take this sword and position it and rotate.
I want to turn. There we go. Just wanted to turn that gizmo off. So let's take this.
Kind of where I'm trying to achieve. Yeah, I think that's about right. One thing that I'm going to want to do is in our player, I don't think we've done it yet. Yep, I'm going to go ahead and add a sorting group. Go ahead and set the sword to the order layer of 1, still on the sword.
Where? That additional setting. Did you add that in? Did I miss that part?
To our player game object, zero it out a bit, and position it
Oh, it's in our sprite renderer that wasn't open. Her.
accordingly. So I'm going to take this sword and position it and rotate it Kind of where I'm trying to achieve. Yeah, I think that's about right. One thing that I'm going to want to do is in our player, I don't think we've done it yet. Yep, I'm going to go ahead and add a sorting group.
Oh, in our player, we're going to add the sorting group. Okay. I don't actually think I've used sorting groups before, so this will be good for me.
Thing that I'm going to want to do is in our player, I don't think we've done it yet. Yep, I'm going to go ahead and add a sorting group. I'm going to go ahead and set the sort to the order layer of 1, still on the sorting layer of default, but even though it's set on the order layer of 1, now if it goes behind the tree, it's going to base the parent root.
Oh, good. Oh, he's still wandering away. Where are you going, buddy?
Object of our sorting group before everything else. So because this order layer is 0, the tree order layer is 0, it's still going to appear that the whole object is behind the tree.
Okay.
And over in Assets, Animations, let's go ahead and create a player folder to kind of clean that up a bit. Player, gonna go ahead and click all these, shift click, drag them on in, and I'm gonna go ahead and create a folder for our sword. Now the way we want to set this up overall for the course in the project is I'm going to create for now an empty game object called active weapon. I'm gonna go ahead and drag.
Coin?
This up here. For now, it's going to be pretty blank, but we do need a parent object for our sword specifically. So I'm going to go ahead and drag our sword into that active weapon empty game object, and let's create a couple animations for our sword. Now it looks like we're going to need those same things that we always need: a sword, animator controller.
Okay.
And we're going to need a slash up and a slash down animation. Let's go ahead and create those. Instead of slash, I'm actually going to call it swing down and swing up. I think that makes sense. Animation, swing. We got the down. Let's go ahead and create the up. And we're also going to need some kind of idle animation. Calling it idle doesn't really make sense because we don't really need it to do anything. So I'm simply just going to call it entry, and I'll show you why we need that in just a second. In our sword, let's go ahead and click that and give it an animator. Perfect.
All right. Sword.
Doesn't really make sense because we don't really need it to do anything, so I'm simply just going to call it entry, and I'll show you why we need that in just a second. In our sword, let's go ahead and click that and give it an animator. Perfect. Let's go ahead and give that to our controller, and I can just go ahead and click this. Sword, click away, click back, and let's go ahead and drag those in. Gonna need an entry point, and we're gonna need a swing down and
Wait, what? This is the animator for my player. Okay, weird.
anything, so I'm simply just going to call it entry, and I'll show you why we need that in just a second. In our sword, let's go ahead and click that and give it an animator. Perfect. Let's go ahead and give that to our controller, and I can just go ahead and click the sword, click away, click back, and let's go ahead and drag those in. Gonna need an entry point, and we're gonna need a swing down and a swing up. And this is actually pretty easy to rig up in the animator. The way that we're gonna do this is 3 really simple transitions that are all gonna use the same animator trigger that we can just call attack. Rig up in the animator. The way that we're going to do this is 3 really simple transitions that are all going to use the same animator trigger that we can just call attack. Let's see if the new Unity lets us change all 3 of these at once. I have a feeling it's not going to, but I haven't actually tried it yet. Ooh, did it work? Attack? No, it only clicked the last one.
Yeah. Okay, I see what he was talking about.
Alright, let's go ahead and condition that as attack. Attack. Perfect. And we don't want any of these to have an exit time or a duration. Ooh, I'm going to try this again. Come on, new version of Unity. Don't let me down. No, it didn't work. Alright, I'm going to go ahead and change that to no exit time and no duration.
Yep, I see what he's talking about.
Set. Perfect.
Trying to get all 3 of them to get the settings all at once.
We can go in and make our first swing down animation. I'm going to go ahead and go to our swing down. Our sword is in about the right spot, and I'm going to go ahead and click the record button. And while I'm...
Hold up.
And now we can go in and make our first swing down animation. I'm going to go ahead and
Alright, change it from entry to swing down.
Go to our swing down. Our sword is in about the right spot, and I'm going to go ahead and click the record button. And while I'm clicked on the sword, I'm going to go ahead and right click somewhere in here and add key. That way we have that base transform dot.
Where?
And go to our swing down. Our sword is in about the right spot, and I'm going to go ahead and click the record button. And while I'm clicked on the sword, I'm going to go ahead and right click somewhere.
Oh, it's in the transform. Okay. Is it? What? Oh. So don't click directly on the bar, click somewhere in the transform box. Gotcha. Add key.
And add key. That way we have that base transform dot position section. I'm going to go ahead and just move a little forward and start animating. I'm going to rotate this a little bit down, rotate it a little bit this way. And the way that we kind of want to do this is keep this somewhat central and smooth, so that way we get this nice swinging animation kind of from here to there while rotating.
So can I change the pivot on it? Wouldn't it make more sense then to pivot it at the hand? Right, yeah. Center at the pivot. Okay. So, I'm going to see if I can make this a little bit easier on myself than what he's actually doing. So, let's go to our sword, sprite editor. Yeah, so let's move our pivot to the very center of the hand. Okay, that is going to move that a little bit. So I think we're going to have to delete these keys. We're still in record. So let's turn that off real quick, because now we need to move this where we want it. But see, now look, the pivot is right at his hand. Just raising it up over his head for a downward stroke. Right about there looks right. And that's where our sword's going to be. Okay. Now we can add the key. Good. Now with that recording, I'm going to move forward a little bit. Let's see how he does it.
Gonna go ahead and just move a few.
Oh, that looks smooth. I like that. Nice. Fantastic work. Oh, what did I just do?
Few more keys forward. Gonna rotate it quite a bit right there. Yeah, I think this is getting the right direction. One more, rotate it quite a bit, bring it on down, and let's try one more to kind of get it into the last position, and let's see how we did. We're definitely going to need to tweak it up. From start to finish, I'm just going to kind of drag it forward. Hey, that was not bad for our first attempt. I'm going to go ahead and polish it up just a bit. So right about there looks pretty good. Right about there looks a little awkward. I think we just need to move that over a little bit. Right about there looks pretty good, but right about here, it kind of comes out a little bit too much for my fancy. I think that needs to come down just a little bit. Moving forward, not
So
bad,
I'm thinking
not bad, but I do think it's
that
a
I
little
kind of
bit
want to have it
too far out from his body.
flip a bit, so then it looks like he's getting ready for a
About
backstroke.
There, I think. And in the last position, I'm gonna actually bring it in.
So let's do something a little wonky here. We're going to kind of turn this a bit. You'll see what I'm getting ready for. Ah, dang it. Forgot to hit the record button. Oh, hang on. What is the rotation? 0, 0. Right, and the Z doesn't change. Oh, the Z does change. But those should be 0 when we get to here. There we go. So as he comes down, yeah, and then gets ready to swing it back. I think this needs to be a little bit closer to make that look crisp. I think actually it's almost like I want it to turn completely over. I think I see what the problem is. It's because the tip's moving too much between the rotation. That looks a little better. You know, maybe I should just not. Mess with that some other time. There we go. I can live with that.
Just a little
I
bit
can
more, so it's
absolutely
kind of
live
like a
with that.
nice tight swing. How does that look? Yeah, that's not bad. I think we might be able to tweak it up a little bit later, but for now, I'm going to just go ahead and speed up that whole animation to 100. Hey, that looks pretty good. And let's go ahead and get the basics rigged up in our script. We're going to head on over to scripts. And the way that I'm actually going to set this up for now is I'm going to create an empty class called active weapon that we're going to put a bunch of code and scripting logic in later. But for now, I just need some way to grab this parent object. So I'm just going to go ahead and create this class and let it compile. And I'm going to go ahead and just drag that active weapon class onto our active weapon transform in our hierarchy. And I'm also going to go ahead and create a sword.
And we'll make a script for our sword.
Script that we're going to attach directly to our sword. For what it's worth, in this lecture specifically, we're just handling the animation first before we set up any kind of collision. Gonna go ahead and drag that onto our sword. Yep, that looks about right. And we're gonna need some kind of signifier in our action map for when we click the left mouse button. Now you can obviously set it as whatever you'd like, but I'm gonna click the left mouse button as we attack in our action map. And this is one reason I really like the new input action map. You can simply just add a new action map. I don't know, let's call it combat.
Oh,
and
whoops.
in here, I can simply call this attack. And in our binding,
Ah.
we can just set that as the left click mouse button. I think it's, how do you click it? Mouse, left button, mouse. Perfect, there it is. Make sure this attack is set to button. Yep, and that's it. Gonna go ahead and save the asset to update our player controls class that we don't have to touch. Go ahead and close that out, and I'll show you the way that we set mouse. Perfect, there it is. Make sure this attack is set to button. Yep, and that's it. Gonna go ahead and
Cool. Cool. Value pass-through. There's probably other real cool stuff that we can do with that that I don't know about
save
yet.
the asset to update our player controls class that we don't have to touch. Go ahead and close that out, and I'll show you the way that we set this up. Go ahead and in our sword script, go ahead and open that up. And similar to what we did before, we essentially need to access that player controls class. So we'll set that up in the exact same way. Private player controls. We'll just name it player controls with a lowercase p, and in awake, we will initialize player controls as a new player controls. Easy peasy.
Yep, that works. Okay. Getting a little bit quicker with the shorthand. We like that.
Don't forget, we need to on-enable.
What do we need to on-enable?
Enable our new player controls. There we go. Make sure we can use it. And the way that we're going to do this is a little bit different than we did in our player controller with a slightly different syntax used. But we also want to access our player controls with an uppercase combat and an uppercase attack like we defined in our action map. And we can go into this, and there's a couple different things we could do. There's started, performed for left mouse click down, or canceled for mouse click up. We're going to go ahead and use started for left mouse click down, which is what we defined in our action map. And then we're going to use this syntax that is a little bit unfamiliar to some people. The plus sign equal sign is simply a notation that we're going to use to subscribe to whatever function we declare to the right of the lambda symbol. The lambda symbol is the equal sign greater sign that we used to essentially declare an anonymous function. So in this case, since we're not passing anything through as a parameter, we simply use the underscore to just say, hey, we're not passing anything through as a parameter. Let's go ahead and create the function.
Okay. That's interesting. I've never encountered that before. And then, was it plus equals or equals plus?
We want to use.
Oh, equals, yeah. Interesting.
Which is going to be attack. And when we left click our mouse button, we want to fire that function. Oh, sorry, plus goes first. There we go. What this
Oh, that's why it was wrong. And then here's our function. Boom. Oh, wait, nope. Derp-a-derp.
Score in our syntax means is we don't want to pass anything through into our attack function. So sometimes you'll see something like context and then pass through that context dot value of some kind that you can get from your action map. We're not passing anything through into our attack function for this, so a nice syntax commonly used in C# is I'd leave this underscore.
Very
And the way that I like to think about this syntax is subscribing to this on-click event, and when we click our event, in other words, left mouse click, our function that we want to fires. And in this attack function, we essentially want to fire our sword animation. Well, that's simple enough. We created that trigger animation in our animator controller as a parameter, I believe is what it's referred to as. And up here, we can do something that we've already done. We're going to access our animator. Let's just call it my animator, and in awake, let's go ahead and initialize that. My animator equals get component animator, perfect. And down here,
Oh, wait, what am I doing? Oh, man, I'm getting tired. We are going to wrap it up after we finish this section. My focus is slowly fading. I'm probably going to do some more work on this on my own later, but I do need to take a break. And that's something that you should take into account when you're learning new things, especially things that are very in-depth, that you have to really think about and focus on. I mean, what, we've been at this for almost 2 hours now. So yeah, the brain definitely needs a break. I need some lunch, I need some brain food, I need some water. I just need to recharge the batteries before we get back to it.
on attack, whenever we left click our mouse button, we simply want to access our animator and fire that trigger that we defined as uppercase attack. All right, that should be about it. Let's head back on into Unity and see if we set that up correctly. I've got my animator tab open so we can kind of see what's going on, and this is the reason we kind of want the entry point. It doesn't really do anything, but if we didn't have that, you can...
Well, duplicate private modifier. Oh. How did that happen? And how did I not notice that? Weird. Alright, we're all compiled now? Okay, so... Well, I hit play the cheat. Gosh. There we go.
imagine it would immediately go towards swing down every single time. Maybe you opened like a new scene, you clicked the play button, you loaded the game.
See that?
And we go
Look at that.
and click the left mouse button. Yeah, perfect. It looks like it's actually working out pretty
Look
good.
at that.
I think I want the animation to be just a tad faster, so I'm going to go ahead and into the animation window, change it to maybe something like 130. Yeah, I think that looks about right. But you'll notice that every other time...
What just happened? How did we break it? Okay. Why did... Okay. It must have just broken it because we left it in the down position. I think that's why. I do think we want to leave that at 100, though. I kind of like that.
When we left-click the mouse button, it defaults back to this up position. Well, that's simple enough. That's because we don't have the swing up animation. And I think that will introduce us to this lecture's challenge. Set up the swing animation. Just like we did with the swing down animation, use the animation record property and get your animation swinging up in a way that makes sense and looks good to you. Go ahead and pause the video and take a few minutes to do that.
Alright, so we're basically just going to do the exact opposite. So what I'm curious about is if I can just mirror this motion. We're going to try something a little wonkier. We're going to do that. I don't want to delete the keys. Can we copy them? Let's see if that works. Okay. Swing up. Oh, perfect. So now we're going to... We're going to flip them. First, we want to... Ah. All right. What are you thinking about? We're going to move all these out to the 20 mark, because what we're going to do, this is going to be wild and crazy. That to our 0. Nope, nope. It's going to go to R5. Oh, hang on, I'm doing that wrong. Looks like there's one block between. Okay. Well, actually, is that going to look... Yeah, that's a good... I mean, it's just the reverse, right? It's a good backswing. Yeah, 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 yeah. I mean, I suppose it could look a little bit different, because, I mean, this looks like a good down chopping right here. Like, right, you're bringing it down and then finishing it through the back. But for a backswing, it really would swing across more before coming up. So here, we're going to change this frame and this frame. It should be more like that. Right? Yeah, and even still here, it should still... I think I like that a little more. That kind of looks like a much cleaner backswing. Backswing finish, and then come back down again. Right? So in theory now, since we've got that set, that should just fire, right? Well, let's try it. Yeah. I don't think the mirrored one was quite good. Quite good. I don't think the mirror one really mimicked... I say realistic, right? I mean, we're looking at pixels here. It didn't quite mimic what we would expect a backswing to look like. This, for pixel art, I mean, this looks smooth, right? This looks, gosh darn, almost realistic. Of course, now we're going to need the animation to flip when we're facing the other direction, but that's a whole other thing. I think we need to speed this up, though. This takes a total of 25 seconds. This one takes a total of 15. So I think we're going to want to stretch this out. So now they should be the same. Right? 5, 10, 15, 20, 25. 5, 10, 15, 20, 25. Now, of course, that's the only thing that's messed up. So let's change this back to 60. Oh, it's the same thing. All right, so this is how we're going to speed it up. We're going to squash this to 20. And then we're going to squash this to 20. And if we have to, we'll move it to 15 and see how that works. Swing, swing. Dancing sword. Yeah, still not fast enough for my liking. So let's squash it some more. Move that to 15. Move that to 15. Now that should look pretty good. Hiya, 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 hiya. We're gonna speed it up just a little bit more. I was having way too much fun with that. All right, that should be perfect. And if it isn't, well, we'll mess with it more some other time. Okay, I like that. That's more crisp. Yeah. Kind of getting like that staggered view now with it moving that fast. Feel like we could probably give it a better visual if we added more keyframes in the in-between. But I digress. All right, let's see how he did it.
Let's go ahead and go through that.
I'm going to laugh if he does just the mirror that I did first without actually adjusting it.
I am actually going to go ahead and cheat just a little bit in a good way. I'm going to go ahead and over to this last frame. I'm going to Control-C this to make sure we get the exact same position as where our sword ended on the swing down animation. Head back on into swing up and just copy-paste that. Perfect. And let's just kind of do the same thing here. Going to go ahead and hit record. Going to move that over a little bit. Rotate it a bit.
Okay, so he didn't do the mirror like I did, but obviously to make sure that your starting positions are the same, you want to use those exact same keyframes, which I did,
rotate it,
just in a slightly different way.
Again. Probably 2 more times, I think it'll be about right. Maybe even just 1, but I think 1, 2, 3, 4. And in the ending position, so somewhere over here. That should be pretty close. Yeah,
I'm surprised he didn't use the last keyframe there.
A little bit, I think, right there. Can probably just be tucked in a little bit tighter, and about right there, just a little bit tighter. I think this can come out just a tad. All right, yeah, that looks pretty good. Click the unrecord button, change that to the same speed as our other one, and hiya! Perfect. With that set up and this already rigged up in the animator, I think we should be able to left click and swing back and forth. Let's go ahead and give it a try. All right, it is working. Yeah. You'll notice if you change to the left side with your mouse and face left, well, that's not exactly what we wanted. We'll go ahead and tackle that in the next lecture. But well done in this lecture. Let's keep on moving forward and let's change it so we can swing both ways and in both directions. I'll see you there.
All right. So that is going to wrap us today, guys. Thank you so much for hanging out with me today. Thank you so much for watching. If you had fun on this adventure, please like, comment, subscribe. Every Wednesday we'll be streaming game dev stuff. I'll be working on it behind the scenes as well too. And this is just the beginnings. So the plan here is we're going to flesh out a really nice combat system. And we're going to then flesh out a really nice quest system. And we're going to follow that with a really nice inventory and ability system. Once we've got those systems built and really situated and set, we're going to then start to reskin everything as we go. We'll probably do a bit here and there just to kind of break up from coding and all that stuff. We'll work on some pixel art and whatnot. We're going to reskin it, and we're going to start storyboarding and trying to build an action RPG of our very own out of these systems that we are creating. And hopefully we'll have a really cool looking project by the end of this whole adventure that we can throw up on itch.io for everybody to try out and check out. And who knows, maybe it'll evolve into something that we can throw up on Steam. But obviously we don't know where this is going to go to. We don't know how this is going to pan out, but I'm glad because I feel like I've got a really good direction for how we're going to be moving forward through our early development phase. But again, guys, thanks so much for joining. Like, comment, subscribe. I'll see you in the next one. Have a good one.